In this lesson, students will be able to fold papers to show equal partitions and generate equivalent fractions. By now, students should have a solid understanding about what a fraction is and be able to represent a given fraction with models. They can find fractions on a number line and are able to reason about their size. Today, they will expand that reasoning and be able to generate two fractions that are equivalent. Let's begin by comparing halves modeled in different ways. Here I have two models. Each is partitioned into two equal pieces or halves. Half of this square is shaded, and half of this square is shaded. In this case, are the shaded pieces equal? Is 1/2 equal to 1/2 using these models? We can see that these are not equivalent fractions. When finding equivalent fractions, we need to remember to refer to the same size whole. This is something to keep in mind when deciding if two fractions are equivalent. So now I'm going to use the same size whole. I want to partition or fold this paper into a different way to show 1/2. One way might be to fold it horizontally like this. Are these partitioned the same way? Are the halves equivalent? I can reorient the paper to see that the halves are equivalent. But what if I took another paper and folded it along the diagonal into two equal pieces? Are the halves on this paper equivalent to the halves on the other two papers? Some students might be able to reason that since the whole was the same and they were both partitioned into two equal pieces, then they are equivalent even though they are different shapes. However, some students may need to see this, so let's cut the diagonal model apart and lay it on top of the other model to compare. As I line it up with my other model, I see I'm going to need to take apart the triangle. Now it all fits in the space of 1/2. This will help students to see that they are equivalent fractions, and as long as they are looking at the same whole, they can find the same fraction in a variety of ways. Let's take this model for halves and look for a fraction that is equivalent to 1/2. Here I have another paper where half is shaded. What if I folded it into fourths like this? We can now see that the shaded part has stayed the same. What has changed is the number of partitions. It now has two shaded pieces out of 4 pieces total, so I know that 2/4 is the same as 1/2. Let's look for one more fraction that is equivalent to 1/2. I now have fourths, but could I make eighths? Well, let me fold this again into fourths. And I know if I divide each of those 4 sections in half, there will be 8 sections. So let's fold it in half one more time. Now I can see that there are 8 total sections and 4 of them are shaded. So 4/8 is also equivalent to 1/2 and 2/4. Give your child additional papers and have them model as many equivalent fractions as they can with denominators of 2, 3, 4, 6, and 8. Our goal today was to be able to fold papers to show equal partitions and generate equivalent fractions. We were able to do this by folding halves, fourths, and eighths and discussing the relationship between them. We also showed that even though the shape of a fraction, like 1/2, may be different, they can still be equivalent as long as the wholes are the same size.